Okay, gonna quickly show how you can prove the root 2 is irrational. So yeah, I mean, I guess it's like pretty famous like problem because you use proof by contradiction. So we're gonna assume that root 2 is rational, which is the same as saying that there exists a and b such that square root of 2 equals a over b, and we're gonna say that this is this is like the most simplified fraction. These are the two smallest numbers, so yeah. Okay, so let's get started. So from this, we can say that 2 equals a squared over b squared, and that 2b squared equals a squared. Okay, so a squared equals 2 times something, so we can say that 2 divides a squared, and okay, this implies that a squared is even, right? But if a squared is even, that actually implies that a is even, which means it can be written as 2 times some integer. Because if you think about it, okay, when you're squaring a number, there's two cases. You square an odd number, well, that's just going to give an odd number, or you square an even number, that's always going to give an even number. So if a square of a number is even, that must mean that the actual number is even too. So okay, and then we're gonna plug this back in up here. So it's gonna give us that 2b squared equals 2n squared equals 4n squared. We can just divide both sides by 2 here. So we get that b squared equals 2n squared. So once again, this tells us that 2 divides b squared, which tells us that b is also even. We'll say that 2m. Okay, and then if we solve this back into our first line, where we assumed that it was equal to a over b, we get that the square root of 2 equals 2n over 2m, which is equal to m over n. So we've found we assume that a and b are the smallest numbers. The quotient is root 2, but we've found smaller ones, and you can always find smaller ones. So therefore we've found a contradiction that root 2 is rational, so this implies that, I don't know if that's the best explanation, root 2 is irrational. Nice.